Hi everybody. So in this video, I'm going to show you how we can work with composite functions. So we'll work through example 1 to understand the notation, and then we'll try some exam style questions. So a composite function is when we substitute one function into another. So if we start with example A, we need to work out f(g) of x. And when you work with functions, we read them from the right to the left. So we begin with the x. And then to x, we apply g of x. And this is x plus 2. And then to g of x, we apply fg of x. And this means we substitute x plus 2 into the x term of f of x. So this will give us 3 lots of x plus 2. So we're substituting all of this into here. So fg of x will equal, we can expand out these brackets, 3x plus 6. Okay? This will be the composite function fg of x. Question B, gf of x. Again, we start to the right, so we start with the x, and then we apply f of x. And when you substitute x into f of x, we get 3x. And then we apply the function gf of x. So now we substitute this term into this x term. And this will give us 3x plus 2. So g f of x will be the 3x plus 2. Notice how this differs from fg of x. For question C, hf of x. Do you want to try and work this one out yourself? Begin with the x term and then work your way to the left. Okay, so we have the x, and then we apply f of x. So we substitute x into here, and we get 3x. And then we apply hf of x. So we substitute this term into this x, and we get 3x all squared, or 9x squared. So hf of x would be the 9x squared. So do you want to try question D yourself? Start with the x term and work your way to the left. Okay, so how did you get on? We have the x and we apply h of x. And this will give us the x squared. And then we apply gh of x. So we substitute the x squared into here. This will give us x squared plus 2. And then we apply fgh of x. So now we substitute x squared plus 2 into here. And this will give us 3 lots of x squared plus 2. And we can expand this out, and we get 3x squared plus 6. This is fgh of x. Okay? So I hope that's given you an idea on the notation for composite functions. Let's try some exam style questions. Okay, so for example 2, we've been given f of x and g of x. We need to work out fg of 3. So there's a couple of ways we could do this. We could work out fg of x and then substitute in the 3. But it's much easier to begin by substituting the 3 into g of x. When we do this, we replace this x with 3. So we get 3 squared plus 3. And this will give us 12. And then we substitute this 12 into f of x. So fg of 3, substituting that 12 into here, will give us 2 over the 12 plus 1, which is 2/13. Do you want to have a go with question B? Okay, so we'll begin by substituting -2 into the f function. So we'll substitute -2 into here. And this will be 2 over -2 plus 1. So 2 over -1 will give us -2. And then we substitute this -2 into g of x. So g f of -2 will be the -2 squared plus the 3. And 4 plus 3 will give us 7. And then for question C, find fg of x in its simplest form. So we need to substitute g of x, which is all of this, into f of x. So fg of x will be the 2 over, and we put all of this into here. So x squared plus 3 plus the 1. And this will give us 2 over x squared plus 4. Okay? And then we can use this to check our answer to part A. If we substitute in 3, we get 2 over 9 plus 4, so 2/13. Okay? Let's try one more question. So in example 3, we've been given the function h of x and t of x. We're told that 1 is excluded from the domain of t of x. This is because we can't divide by 1 take away 1. This would be undefined. We need to work out ht of x. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back. How did you get on? We need to substitute t of x, all of this, into h of x. So ht of x will be the 2 multiplied by all of this squared. So 1 over x minus 1 squared. When this will be 2, but when we square the 1, we get 1. So 2 over x minus 1 squared. Okay? And this is ht of x. For part B, solve this equation. So now we're told that this equals 18. So 2 over x minus 1 squared will equal 18. We'll move this to the right-hand side. We get 18 lots of x minus 1 squared. We'll expand out this bracket. So we get x squared minus 2x plus 1. We'll multiply out these brackets. So 2 will equal 18x squared minus 36x plus 18. And then we'll take away 2 from both sides. And we get positive 16. Now we can factor out the 2. So we get 9x squared minus 18x plus 8. And then we can factorize this. This will be 3x minus 2 multiplied by 3x minus 4. So x will equal 2/3 and x will equal 4 over 3. Okay? Well, I hope that's given you an idea on how we can work with composite functions. If you found that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.